In DC machine, the length of wire, it is a conductor. To know the lap winding, wave winding detail, before that, it is an introduction towards winding process in a DC machine. In every machine, it is the winding is very important. So how the winding is connected in the machine? Here we have the two windings. One is the field windings and lap armature winding. So the field winding of DC machine is a concentrated winding, and armature winding of DC machine is a two types. One is lap winding and wave winding. So the before to understand the winding process, we should know the what is conductor and what is turn. So the conductor is a first one. Conductor is a the length of wire lie in the magnetic field in which EMF induced, current flows, torque produced, energy conversion takes place. So that active part of a wire. So the conductor is a active part of the wire which is under the magnetic field is called the conductor. The active part of the wire which is under magnetic field is called the conductor. So the end connection are overhang. So before here in a conductor the EMF is induced and current flows and torque will be produced, and there is a energy conversion also takes place in the conductor. So it is very important that the conductor, it has two side, then it is a coil. The conductor two side conductors is connected by the end rings, then we can say the coil. End connection are the overhang, the length of the wire which not exposed to the flux, in which no EMF induced, no current flows, no torque produced, no energy conversion takes place. So this is called end connection or overhang. So the it can be say that it is very important to connect the two conductor sides, two conductors. So we can see from the figure BOC and AOD are the end connection or the overhang. So here there is no energy conversion takes place and no EMF induced. No energy conversion takes place and no EMF. So a conductors, we can see the AB is a one conductor and CD is a one conductor. We have two conductors in this figure. These two conductors are end connected at B to C through the BOC and AOD end connections. To provide a continuous path, end connections are used. To provide a continuous path, end connections are used. Turn, it consists of two conductors T equal to Z by 2. It consists of two conductors. The turn T equal to Z by 2 means Z is the number of conductors by 2. So if it is a two conductor side, then the two conductors Z is a 2, then 2 by 2 equal to 1 turn. So coil consists of one or more number of turns. One coil is a one turn single turn coil. So we can say here is a one turn coil because turn equal to Z by 2. Here Z is a 2 by 2. 2 by 2 is a one turn coil. A coil two turn two-turn coil is, so see in the figure a two-turn coil. We can say that two-turn coil because of we can observe here is the four conductors we have. 1 2 3 4 conductors we have in the second figure. So the number of turns T equal to Z by 2. The Z is the 4. 4 by 2 equal to 2. Two-turn coil here. So we can say simply it is a two-turn coil. The first figure is a one-turn coil because of two conductors. 2 by 2 equal to 1 turn. And here 4 by 2 equal to 1 two-turn coil. Multi-turn coil. This is a figure of representation of multi-turn coil. Always coil consists of the two ends irrespective of the number of turns. Number of coils that equal to 1 by 2 US. The U means number of coil sides per slots. S equal to number of slots. 1 by 2 U by US. Number of commutator segments equal to number of coils that equal to 1 by 2 US. US means that is coil sides. S is the slots. Number of coil side per slot. Number of commutator segments equal to number of coils, and that equal to number of coil side per slot by 2. Number of coil side per slot by 2. Number of commutator segments equal to number of coils equal to 1 by 2 US. Coil sides are winding elements. Coil with any number of turns contains two coil sides only. Number of coil sides equal to 2C, that equal to US. 2C means two coil side and US is a coil side per slot. Number of conductors per coil side equal to number of turns. It is very important in a competitive exams. Number of commutator segments equal to number of coils, and here number of coil sides equal to 2C, that is U into U means coil side per slot. Number of conductors per coil side equal to number of turns. So next one more important, pole pitch. Pole pitch. It belongs to the one pole. So very important. The pole pitch is belong to the one pole. So it is a distance measured between two consequent point in a area. It is a distance measured between two consequent pole in an area. Pole pitch mentioned in terms of electrical degrees. You remember that. So pole pitch is mentioned in terms of electrical degrees. So slots, electrical degrees, and slots, coil sides. So we should remember that. We know the slot. What is slot? And electrical degrees. Theta electrical equal to P by 2 theta mechanical. Electrical degrees. Theta electrical equal to P by 2 theta mechanical. Theta electrical equal to P by 2 theta mechanical. Slots. The slots are, it is to accommodate a conductor. The slots are placed on the outer ferry of the rotor. And coils. The coil is a combination of conductor. The connection of conductor. If two conductors are there, then it is a one coil. So the coil sides are the two sides of the coil. Peripheral distance between identical points of the adjacent pole is called pole pitch. So you can see here from north pole to south pole, these are the two consequent poles. It is a distance measured between two consequent poles. north to south is called pole pitch. Okay, two pole per revolution, one cycle 360 electrical degrees of EMF induced. Four pole per revolution, so it is a four pole machine. It is a consequent distance measured between two consequent poles, north to south. It's called pole pitch. Two cycles equal to 720 degrees electrical degrees. Pole per revolution, P by 2 cycles. Theta electrical equal to P by 2, theta mechanical. Always electrical degrees only mentioned. Always electrical degrees only mentioned. So because of pole pitch belongs to electrical degrees. Pole pitch is always 180 degrees electrical. So the pole pitch is always 180 degrees electrical degrees. But when it is a four pole machine, so the from distance measured from north to south is electrically 180 degrees, but mechanically 90 degrees, because theta electrical equal to P by 2 theta mechanical. Theta mechanical is if you want a theta mechanical, then theta mechanical equal to 2 by P 2 by P theta electrical. So substitute the theta mechanical equal to 2 by P. P is a 4 and theta mechanical, sorry, theta electrical. So now the theta mechanical equal to 2 by P in place 4 and theta electrical is a 180 degrees. So 2 by 4 it is a 1 by 2. 1 by 2 of 180 equal to 90 degrees of theta mechanical. It is equal to 90 degrees of theta mechanical. So the theta electrical is always 180 degrees, that is equal to pole pitch. So the pole pitch is 180 degrees electrical. So it can be say the slots per pole. The pole pitch is equal to slots per pole. To C by pole. In terms of coil side, two coil sides per pole. C by P. Pole pitch is distance between identical points of adjacent poles. It is a distance measured between two adjacent poles. Coil span or coil pitch. It is the distance between top and bottom coil sides of the coil is called a coil span. Or we can say the coil span. It is a distance measured between two coil sides is called coil span. Again, a coil span. It is a distance measured between two coil sides is called coil span. It is a distance measured between two coil sides is called coil span. North to south. Coil span is a beta YCS equal to SP. If YCS integral full pitched coil, if YCS not integral fractional pitch or it's not integral. So the integral and a fractional winding means the number of slots per pole per phase are integral value, then it is an integral winding. Fractional winding means the number of slots per pole per phase are a fractional value, then it is a fractional winding, fractional pitch winding. So it is clear that A coil span means it is the distance measured between two coil sides is called coil span. A pole pitch means it is the distance measured between two consequent poles. It is the distance measured between two consequent poles in an air gap is called pole pitch. Coil span is the distance measured between two coil sides is called a coil span, beta. So consider the nearest least integral short pitched coil. If we consider the nearest next integral over pitched coil. If coil span equal to pole pitch, that is a 180 degrees electrical, that is slots per pole. It is very important again. If coil span equal to pole pitch, that equal to 180 degrees electrical. The coil span means it is a distance measured between two coil side is called coil span. That coil span is equal to pole pitch, then it is called full pitched winding. A full pitched coil, the coil span is 180 degrees electrical, that is slots per pole. If coil span is less than pole pitch, or that is less than 180 degrees, that means the coil sides, the distance between two coil sides are less than 180 degrees, then that is called short pitch winding. The slots per pole is less than coil span, then the coil is called short pitched coil. So the simply here full pitched coil means the distance measured between two coil sides is equal to 180 degrees, then it is a full pitched winding. If the distance measured between two coil sides are less than 180 degrees, then it is a short pitched winding. And over pitch means if the distance measured between two coil sides are greater than 180 degrees, then it is a over pitched winding. So here in a DC machines you use the full pitched. In AC machine you use the short pitched coils. In a DC machine you use the full pitched coils, and AC machine use the short pitch coil. Connection, see here, it is a lap connection, very important. If a lap connection is only mentioned, then consider the simplex progressive lap connection has to be considered. Progressive. Simplex progressive lap connection has to be considered. In lap winding, ending of one coil connected through the commutator to starting end of the next coil, which is under the same pole. Again, in a lap winding, ending end of the one coil, that is first coil, connected to through the commutator to starting end of the next coil, which is under the same pole. Again, in a simple manner, ending end of the first coil, see the ending end of the first coil means in figure the 10th conductor ending end is connected to the beginning end of the second coil, beginning end of the next, that means second or the next coil. In a figure 3, see the figure, the conductor 3, that is the beginning end of the next coil. So ending end of the first coil, that is 10th coil ending end, is connected to the beginning end of the next coil. Next coil is the third coil, that beginning end is the third coil beginning end. It's connected, is called under the same pole, we should remember that under the same pole is called lap winding machine. It is called lap connection. So we can see here YB is the back pitch, YW is the winding pitch, YF is the front pitch, and YC is the commutator pitch. YC is the commutator pitch. The commutator pitch means it is the distance measured between two commutator segments is called a commutator pitch. Wave connection, so it is the winding is like a wave. It is a like a parallel connection. The all conductors are like parallel connection. So these are the like series in structure, series connection. It is a series connection. So N1 S1 N2 S2, N1 S1, that is the north pole 1, south pole 1, north pole 2, south pole 2. Here we can see the two coils from 1 to 10, and here again. So we can see by the diagram that we can define that from the diagram, the beginning end of the first coil, beginning end of the first coils mean the ending end of the first coil. The ending end of the first coil, that is the 10th conductor ending end, it is on south pole 1, under the south pole 1, the conductor which is under the south pole 1. Again I am telling that repeating, the ending end of the first coil, ending end of the first coil, see here. So ending end of the first coil which is under S1 pole, ending end of the first coil is connected to the beginning end of the next coil which is under N2. Ending end of the first coil is connected to beginning end of the second coil through the commutators under adjacent same pole, adjacent same pole, adjacent poles. It is adjacent here which is under the same pole, it is under the same pole, but it is a adjacent pole, it is not an N1, it is a N2. Then it is called wave connection. The wave connection other name is also called a series connection, and lap connection is also called parallel connection. So a lap connection is for low voltage high current application. Lap connection is for low voltage high current application, and wave connection is for high voltage low current application. Wave connection for high voltage low current application. The ending end of the coil connected to the starting end of the next coil through the commutator which is under the adjacent pole. So that is a wave winding definition. Okay, the ending end of the one coil connected to the starting end of the next coil through the commutator which is under adjacent pole. So now simplex progressive lap winding. The progressive lap winding means here back pitch is greater than the front pitch. So you should remember that a progressive lap winding, the back pitch is greater than front pitch. As winding is progressive which moves left to right, the winding which moves from left to right as seen from the commutator side is called a progressive winding. So we can observe here the left L is the left, R is the right. If the winding process is moves from left to right, moves from left to right is called progressive winding. Progressive winding. Simplex retrogressive lap winding. As winding progress, which moves from right to left, right to left, we can observe the R to L, the right to left, as seen from the commutator side, is called a retrogressive winding. In a retrogressive winding, back pitch is less than a front pitch. The front pitch is greater and back pitch is less. Progressive winding, YB is greater and YF is less. In a retrogressive winding, YB is less and YF is greater. In a progressive and a retrogressive winding, the difference lies in only front pitch. Back pitch remain same in both the windings. So the front pitch and back pitch are different, but not all connection. So here the retrogressive windings moves from right to left and progressive windings moves from left to right. To avoid the cross problem, progressive winding is a considered. To avoid a crossover problem, progressive winding is the best suitable. So the mostly the machines are designed with the progressive windings. Back pitch is greater and front pitch is less. So slot number 1, coil side number 1, slot number 2, coil side number 3, slot number 3, coil side number 5. Commutator segments are the number 1, 2, 3, 4, 5. Duplexive progressive lap winding. It consists of two simplex lap which are placed in a alternate slots connected to alternate commutator segment. Slot number 1, 2, 3, 4. You can see that in figure. So this is a duplex progressive lap winding. In a two-pole machine, lap connection and wave connection is same. A equal to P equal to 2. I path, the current per path equal to 10 amps. IL equal to 20 amps only. Load current is at 20 amps only. By using the flexible winding, we can improve the current and power rating as number of parallel paths is increased. Current and power rating as number of parallel paths are increased. Composite winding or frogging winding. Composite winding or frog leg winding. In a lap winding, there is a disadvantage of flow of circulating current. In a wave winding, there is a disadvantage of requirement of dummy coils. Equalizer rings are required in a lap winding. This disadvantage can be overcome in a composite winding. This composite winding is used as in a large rating machine. So composite winding, a lap winding, this disadvantage of flow off. So we can say that lap winding is a complete winding, and wave winding is a incomplete winding. In a lap winding, because of complete winding, the current flows in a lap winding is higher values. So higher current flows in the lap winding. That higher current has to be distributed equally at equalizer rings. So at commutator, so equally distributed at commutator, it is by the equalizer rings. In place of equalizer rings, we use the frog leg windings. So equalizer rings or frog leg windings are used in the lap connection to distribute the current equally at commutator segment. But in a wave winding is a incomplete winding. Because of incomplete winding, there is a dummy coil placed in a machine. This dummy coil is physically present but electrically absent. In a wave winding, because of incomplete winding, the current ratings are very less, voltage ratings are high. Because of current ratings are low, so to distribute current equally at commutator segment, there is no need of equalizer rings in a wave winding. So these frog leg windings are only used in the lap winding machine because to distribute current equally at commutator segment. And these frog leg windings are mostly used in the large rating machines. Back pitch. Distance between top bottom coil side. Top bottom coil side of a coil which is measured away from the commutator side. The back pitch is approximately equal to the pole pitch. In terms of coil side, back pitch is always odd number. So this is the formula of YB 2C by P plus or minus K. So YB is the back pitch, that is equal to pole pitch in terms of coil side. So K may be added or the subtracted from the 2C by P to make YB a odd number, because back pitch is always odd number. If U equal to 2, average pitch, YA equal to YB plus YF by 2, that equal to pole pitch. If U is greater than 2, U means coil sides. The coil sides are greater than 2. The back pitch U YB minus Y by U, that is an integer. Minimum number of coil side has to be selected is 2. If it is not mentioned, coil span or coil span pitch. The coil span pitch is the YCS, coil span pitch, that equal to slots per pole nearest to least integral value. Front pitch. It is the distance between two coil sides which are connected to a same commutator segment. It says that a distance between two coil sides which are connected to same commutator segment. Front pitch is always odd number. In simplex progressive, YB equal to YF plus 2. Retrogressive, YB equal to YF minus 2. back pitch equal to front pitch plus 2. Retrogressive back pitch equal to front plus front pitch minus 2. In a duplex winding, the progressive winding, yb equal to yf plus 4. Retrogressive winding, yb equal to yf minus 4. Front pitch expressed in terms of coil side. For a simplex lap winding, yf equal to yb plus or minus 2. For a multiplex lap winding, yf equal to yb plus or minus 2m. Plus for retrogressive winding, minus for progressive winding. M equal to 1 for simplex winding, M equal to 2 for duplex winding, M equal to 3 for triplex winding. In a wave connection, there is no relation between back pitch yb and front pitch yf. In a wave connection, there is no relation between back pitch yb and front pitch yf. Winding pitch or a resultant pitch yw. So winding pitch, it is the distance between consequent top coil sides or a consequent bottom coil sides. Always resultant pitch is even number in lap connection. Yw equal to yb minus yf. Yw equal to yb minus yf. Always resultant pitch is a even number in a lap connection. So in wave connection, yw equal to yb plus yf, that is winding pitch equal to back pitch plus front pitch. In simplex progressive lap winding pitch equal to 2. Simplex retrogressive lap winding pitch equal to minus 2. Duplex progressive lap winding pitch equal to 4. Duplex retrogressive lap winding pitch equal to minus 4. For a multiplex lap winding pitch equal to plus or minus 2m, m equal to 1, simplex winding. Plus for progressive winding, minus for a retrogressive winding. Commutator pitch yc equal to distance between commutator segment to the which two ends of same coils are connected. It is measured in terms of commutator segments or coils. Always commutator pitch is integer in case of lap connections. In simplex lap progressive retrogressive, yw equal to 1, yw equal to minus 1. In duplex lap progressive winding, yw equal to 2, retrogressive yw equal to minus 2. For multiplex lap, yw equal to plus or minus m, plus for progressive, minus for retrogressive. Plus for progressive, minus for retrogressive. For a multiplex lap winding, at equal to plus or minus m. In a wave connection, commutators connection, commutator pitch can be fractional also. In wave connection, if Yc is an integer, then no need of dummy coils. Yc equal to integer, and dummy coils are required. Yc is not equal to integer. So these are identification of number of dummy coils of a machine. So total coils C dash equal to 1 by 2 U by S. Active coils C equal to P by 2 Yc plus or minus M. C dash greater than C. Number of dummy coils required equal to C dash minus C. Wave connection YCS equal to S by P. YB equal to Y UYCS plus minus 1. Winding pitch equal to winding pitch equal to back pitch plus front pitch. Distance between the consequent top coils or consequent top coil. Winding pitch approximately equal to 2 pole pitch. Winding pitch equal to 2 pole pitch. In terms of coil sides, in 2 pole machine 2 by 2 winding pitch 2C plus or minus 2. In 4